Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And again, this was a one that required quite a bit of time of preparing, but it was fun. And at least part of this I have always found sort of fascinating as to how the sun changes its path across the sky from the winter to the summer, and also what makes the jet stream stronger during the winter than during the summer. So hopefully you will find it at least somewhat as interesting as I do. And so let's move on ahead here. So what I did was I took a look at the normal highs, or the 30-year average from 1991 to 2020, for 3 different cities. International Falls, Minnesota, which is right on the Canadian border, Kansas City, Missouri, and Houston, Texas. And if you take a look at those 3 lines, do you notice how they're much closer together in the middle of the summer than they are during the winter? In fact, in the middle of winter, middle of January, the normal high in Houston is about 63, okay? And the normal high in International Falls is 15, okay? So that's about a 48-degree difference. Whereas here in the middle of summer, the normal high in International Falls is 78 or 79, and in Houston it's 95. So that's about a 17-degree difference there. So a big, big difference. And another way to look at this is to actually plot that difference. So again, it's about a 48-degree spread in the middle of winter, but only about a 17-degree spread in the middle of the summer, okay? Now, you know how we've talked about surfaces of constant pressure, and the farther apart they are, the warmer the air is, and the closer together they are, the colder it is. So let's take a look at this from that standpoint. So this is why the jet stream is stronger during the winter time, is that here we have 2 surfaces of constant pressure, 1,000 millibars, 500 millibars, which is up at about 18,000 feet. So these lines of constant pressure have got to be much closer together here where it's bitterly cold up in the polar regions, as opposed to in the equatorial regions where it's still pretty darn warm, okay? So this 500 millibar surface slopes very steeply, which means if you're looking along any one given elevation, the pressure drops from 500 millibars here to a much, much lower value as you head over here because you're that farther away from the 500 millibar surface. So you have a stronger pressure gradient or difference, and that's what drives the wind. And so the jet stream is always stronger in the wintertime than it is during the summer. However, if we take a look at the summer scenario, where it's hot down here in the south, but pretty darn warm up north. I mean, there's not nearly as big of a separation of temperature. And so that means that 500 millibar surface has to slope much less steeply, which means at any one given elevation, the pressure gradient is going to be much less. And that means the winds are going to be much less at that altitude. And so the upper level winds always are much weaker in the summer than they are during the wintertime. And that's why you don't see these big storms during the summer season, other than hurricanes, okay, which is those storms get their energy from a completely different source. But you're not going to see a deep low moving up across the United States in the middle of July because there just isn't enough energy available from the jet stream to produce such a storm. But there's another thing that comes into play here, okay? So what you're looking at here is the path across the sky that the sun takes at 4 different latitudes on June 20th, the first day of summer. The equator, 20 degrees north, 40 degrees north latitude, and 60 degrees north latitude. The latitude of the RDU airport is almost 36, so 40 would be the closest approximation to what we observe here. So, at our latitude, or close to our latitude, at 40 degrees north, this green line here, you notice how we start off in the northern part of the sky, and that's the case all the way from March 21st to September 21st. And then as the sun gets higher in the sky, it crosses over into the southern part of the sky for most of the day, and then comes back into the northern half as it sets. And I think I've mentioned this before, where as a kid, when I first started getting interested in the weather, that people would say, well, put that new thermometer you just bought on the north side of your house because it'll keep it in the shade all the time. No, it won't. Not from March to September it won't. It'll get hammered with sunshine in the early part of the day and the late part of the day. So that doesn't work during that 6-month period. Now, if you go up to 60 degrees north, look at this. The sun rises way in the northern part of the sky, comes all the way around here into the southern part of the sky, and then comes back here. And if you head even farther north, okay, like north of the Arctic Circle, this line links up with this line, which means that there's continuous daylight for 24 hours, okay? The sun never goes down, and at the North Pole, it doesn't go down for 6 months. So what I wanted to point out here, and the red line is what happens at the equator, and if you think about it, the sun is at about 23.4 degrees latitude north on June 20th. The equator is actually south of there, and so at the equator, the sun spends its entire day in the northern part of the sky. But here's the other thing. The path that the sun takes at the equator, that's a much shorter path than this one here at 60 that goes all the way around like this. Now, admittedly, the sun is lower in the sky at 60 degrees north, and the sun's rays aren't nearly as direct. But if you give it like an extra, I don't know, 6, 7 hours of daylight or whatever, that's going to have an effect, okay? So again, that is why the farther north you go, from March to September, the days actually get longer. And as a result, the difference between the temperature in the tropics as opposed to the Arctic is not nearly as big. Now, here's what it looks like on the first day of winter, okay? Now, in this particular case, if you think about it, the equator is at 0 degrees latitude, and the sun is overhead at minus 23.4 or 23.4 degrees south. And so for all of these places, the sun spends the entire day in the southern part of the sky. So here's the equator, and then here is, let's see, 20 degrees north, 40 degrees north, which is about where we are, okay? So the sun only gets to about, well, at 40 degrees north, it only gets to about 26, 27 north latitude. I think we get to about 30 here. And then at 60 degrees north, it barely even comes up. And again, north of the Arctic Circle, you have continuous darkness. And at the North Pole, you have darkness for 6 months, okay? So the difference between the sunrise and the sunset, between the summer and the winter, is massive in the northern regions, okay? Whereas at the equator, it really doesn't change all that much, okay? So a lot more contrast headed north than you do headed south. All right, I hope that makes a little bit of sense and you found that interesting. That is bonus weather video number 3 for this week. The next one will come up on Monday, and the next daily update Monday as well. If any severe weather happens to be occurring on Sunday or is likely, I will definitely update you on that at the appropriate time. All right, you have a wonderful Friday evening, an even better weekend, and we'll talk to you Monday. See you later, everybody.